Your test covers sections 1.3, 1.4, and 1.5. Everything that's on your review will be on your test when you go to take it. Your review starts with giving you two functions and telling you to find the value of each. So with 1 through 4, it gives you f of x equaling 4x plus 11 and g of x equaling x squared minus 3x plus 7. For number 1, you are finding f of negative 2. So that means you're going to take that f of x part and plug in that negative 2 anywhere you see an x and simplify using order of operations. So for this one, you're going to have 4 times negative 2 plus 11. Your 4 times negative 2 would go first, so that's negative 8 plus 11, which gives you 3. For number 2, you're finding f of 2x plus 5. So in your f of x, the 4x plus 11, you're replacing the x with the 2x plus 5. So that's going to give you 4 times 2x plus 5 plus 11. First thing we're going to do is distribute the 4 in. So that's going to give us 4 times 2x, which is 8x, and 4 times 5, which is 20, plus 11. Your 20 plus 11 are like terms, so that gives you 8x plus 31. For number 3, you're finding g of 4. So now you're going to take that g of x equation or expression and plug in the 4 anywhere you see an x and simplify. So that's at x squared minus 3x plus 7. You're plugging the 4 in for x to get 4 squared minus 3x, which is minus 3 times 4 plus 7. You'll do the 4 squared first, which is 16. Minus 3 times 4 plus 7. Your negative 3 times 4 is negative 12. So that's 16 minus 12 plus 7. Your 16 minus 12 gives you 4. And 4 plus 7 is 11. For number 4, we're finding g of x minus 2. So again, we're going to plug that into that x squared minus 3x plus 7. So that's going to give us x minus 2 squared minus 3 times x minus 2 plus 7. We're going to rewrite that x minus 2 squared to be x minus 2 times x minus 2. We're going to keep the minus 3 times x minus 2 plus 7. From here, we're going to FOIL out the x minus 2 times x minus 2. That'll give us x squared minus 2x plus 4. We can also distribute that negative 3 in to get negative 3x plus 6 plus 7. From here, we're just going to combine like terms. That x squared is going to drop down. You then have the negative 2x minus 3x, which is going to give us negative 4x minus 3x is negative 7x. And then you have the 4 plus 6, which is 10, plus 7 is 17. So that's x squared minus 7x plus 17. The next section within your review asks you to state the domain from the given functions. Remember, with your domain, if there is no fraction or no square root, it is all real numbers, so from negative infinity to positive infinity. If there is a fraction, does not matter what's on the top, take what's on the bottom, set it not equal to 0, and solve it. For anything that has the square root, doesn't matter what's outside the square root, take what's under the square root, only the part that's under the square root, set it greater than or equal to 0, and then solve. For number 5, you have f of x is equal to 3x squared plus 6x minus 7. There's no fraction, there's no square root, so automatically it's all real numbers. You get from negative infinity to positive. For number 6, you're given g of x is equal to 5x plus 8 over 3x minus 7. You have a fraction with this one, so we said take the denominator, set it not equal to 0, and solve. So it doesn't matter what's on the top. That 5x plus 8 does not matter. The 3x minus 7, you're going to take that and set it not equal to 0. You're going to move that 7 over using addition. So we'll add it to both sides to get 3x is not equal to 7. And then to get x by itself, we're going to divide each side by that 3, and you'll have x is not equal to 7 over 3. Now, in the past, I've asked you to use your interval notation for this. I'm not going to ask you to give the interval notation for your test. So as long as you give me x is not equal to 7 over 3 for a question like this, then you're fine. I'm not looking for anything else other than that. For number 7, you have h of x is equal to the square root of 8x minus 11. You have a square root here, so you're going to take just the part under the square root. If there was like a 1/3 times the square root of 8x minus 11, and then a plus 2 at the outside of it, the other stuff doesn't matter. The only thing that matters is the part that's underneath the square root. So you're going to take that 8x minus 11, set it greater than or equal to 0, and solve for what x can be. Move your 11 over, adding it to both sides. That gives you 8x is greater than or equal to 11. Then divide each side by the 8, and you have that x is greater than or equal to 11 over 8. That's the only thing I'm looking for. For number 8, you're given k of x is equal to 4x plus 5. Once again, just like number 5, you have no fraction, you have no square root. So you're going to give from negative infinity to positive infinity or all real numbers for your answer. For 9, 10, and 11, it tells you to state if the given function is even, odd, or neither. For these questions, you can use 2 and negative 2, 3 and negative 3. You can even use 1 and negative 1, but I would not. So I'm going to use 2 and negative 2 with these. Find f of 2, g of 2, h of 2, then find f of negative 2, g of negative 2, h of negative 2, depending on which one I'm working on. So if we look at number 9, it gives us f of x is equal to 3x squared plus 2x. We're first going to find f of 2. So that's going to be 3 times 2 squared plus 2 times 2. Your 3 times 2 squared gives you 3 times 4 plus 2 times 2. This then gives you 12 plus 4, which is 16. So f of 2 is 16. Your f of negative 2 is going to be 3 times negative 2 squared plus 2 times negative 2. Your negative 2 squared is 4, so that's 3 times 4 plus 2 times negative 2. That gives you 12 plus negative 4, which is 8. So if your f of 2 is 16 and your f of negative 2 is 8, these two are not the same number, nor are they the same sign. So because it is neither, or because they are two totally different numbers, this is neither. For number 10, we're given g of x is equal to 7x cubed plus 2x. We're going to find g of 2 first. So that's going to be 7 times 2 cubed plus 2 times 2. You're going to do your power first. So that's 7 times 8 plus 2 times 2. Your 7 times 8 gives you 56. And your 2 times 2 is 4. So that means g of 2 is 60. You're now going to find g of negative 2. So that's going to be 7 times negative 2 cubed plus 2 times negative 2. This will give you 7 times negative 8 plus 2 times negative 2. You'll do the 7 times negative 8, which is negative 56. And the 2 times negative 2 is negative 4. So this gives you g of negative 2 equaling negative 60. If you see that the 60 and the negative 60 that you get when you find g of 2 and g of negative 2 are opposites, so that means that this function is odd. So like we said, 11, we have h of x is equal to 2x to the 4th power plus 9x squared. If you find h of 2, that's going to be 2 to the 4th, or sorry, 2 times 2 to the 4th power plus 9 times 2 squared. Your 2 to the, or sorry, your This is 2, not 4. 2 to the 4th power. Your 2 to the 4th power is going to be 16, so that'll be 2 times 16 plus 9 times 2 to the 2nd power. Your 2nd power on the 2 is also 4, so 2 times 16 plus 9 times 4. Your 2 times 16 is 32. Your 9 times 4 is 36. You're going to add these to get 68 for your h of 2. Next, you're going to find h of negative 2. So that's going to give you 2 times negative 2 to the 4th power plus 9 times negative 2 squared. Your negative 2 to the 4th power is going to give you 16. Your negative 2 to the 2nd power is 4. So this will simplify doing your 2 times 16 to be 32, plus your 9 times 4 is 36. So your h of negative 2 is equal to 68. These two are the same number, same sign. So because they're the same, this function is even. For 12 and 13, it tells you to state the domain, the range, the increase, decrease, constant, maximum, and minimum of the given graphs. Remember, domain, increase, decrease, and constant are all your x's. Your range, your maximum, and your minimum are all your y's. So if we look at number 12, your domain, you're going from negative infinity up to 11, and you stop for those x values that are being covered. So that means your domain is from negative infinity to 11 with the bracket on the 11 because there's a closed circle on that 11. However, look at what you're working with. You have an open circle on that negative 5, which means your line does not include that negative 5. So you're going to backtrack this, and you're going to go up to that negative 5, but you're not going to include it. And then you're going to pick back up from that negative 5 and go to the 11 and include the 11. So that negative 5 has the open circle on it. It does not get included. So that's why there's parentheses on it, and you have to separate it and include both parts for your domain. Your range are your y values. So your y values are starting from the lowest of negative 7 and going up to the highest of 10. Your range, although that open circle is in there, because it is filled in here, that y value is covered, so it includes it. So you don't have to worry about any kind of interval notation like you did for your domain. You're just going from negative 7 up to 10. And then brackets on both because you have closed circles and your line is solid. Domain are your x values. So lowest x value to highest x value. You have that open circle on the line, so the x value at that open circle, which is the negative 5, doesn't get included. So you have to separate your interval notation to go from negative infinity to negative 5. Put the parentheses on that negative 5 so it doesn't include it. Then go with a union from that negative 5. Again, parentheses on that negative 5 because it doesn't include it, up to the 11 with the bracket on there because there's a closed circle on the 11. Next, we're going to look for our increase. Remember, your increase happens where your x values are going up from left to right. So from left to right, your increase is happening here. So that's going from that negative 5, not including it, to the positive 1. So your increase, your I, is from negative 5 to 1, parentheses on the negative 5, bracket on the 1. Your decrease are the x values and where the line goes down from left to right. So you are going down from left to right from the 4 to the 11. Brackets on both because there's closed circles at both. Your constant is where the line goes flat. So that's from negative infinity up to that -5. And then from the 1 to the 4. So from negative infinity to -5, parentheses, with a union of 1 with a bracket, comma, 4 with a bracket. Your maximum is the highest y value. So your highest y value that's being covered is at 10. Your minimum is the lowest y value that's being covered, which is at the -7. For number 13, we're going to start with your domain. For your domain, you are covering the x values from negative infinity all the way to positive infinity because you have those arrows at both sides of your line. There are no open circles within it, so every x value is being covered. Your y values for your range, the lowest y value that you have is that -3 all the way up to positive infinity because your arrow on the left goes up to positive infinity. So we're going to go bracket -3, comma, infinity, close parentheses for your range. Your increase values, you have more than one here. From left to right, you are going up from that -8 to that -6. Then again, from the 2 to the 8. So your increase goes bracket -8, comma, -6, close bracket, with a union of bracket 2, comma, we said that was 8, close bracket. For your decrease, you have 2 of those as well. One that goes from negative infinity up to -8, and the other that goes from the -1 to the 2. So your decrease is going to go negative infinity, comma, -8, close bracket, with a union, open bracket, -2, comma, 2. Is that -2 or is that, yeah, that's -2. Next, you go with your constant. So you're going flat in 2 places. One from -6 to -2, and then another from 8 to infinity. For your maximum, your y values, max y value that's being covered is going to be positive infinity. For your minimum, the lowest y value that's being covered is going to be at -3. For 14 and 15, you're told to state the transformations from each of the given function rules. For 14, you're given g of x is equal to -2 times 2/3 x minus 1 squared plus 6. We're going to start with the negative that's out front of that 2. That negative reflects vertically, so it goes over your x-axis. So you're going to say that there's a reflection over the x-axis. Next, we're going to look at the 2. That 2 is greater than 1. So that means we have a vertical stretch by a factor of 2. Inside your parentheses, in front of the x, that 2/3 is going to turn into 3 over 2. That 3 over 2 is greater than 1. So you have a horizontal stretch by a factor of 3 over 2. Next, your -1 is opposite of what you think since it's on the inside still. So that means we're going to the right 1 unit. And that +6 on the outside means we're going up 6 units. For 15, you're given h of x is equal to 1/7 times the square root of 4x plus 3 minus 5. For this one, we're going to start with the 1/7. That 1/7 is less than 1, so that means we vertically shrink by a factor of 1/7. Then on the inside of that square root, that 4 turns into 1/4, which is less than 1. So we have a horizontal shrink by 1/4 as well. Next, you have that +3. You're going to think the opposite, so we're going left 3 units. And lastly, you have that -5 on the outside, so it stays as is, which means we go down 5 units. For the last section in your review, you're writing the function rule for the parent function f of x is equal to x squared for the given transformations. So we're going to start with the x squared, and we're going to add in all of your transformations. For number 16, you have a reflection over your x-axis, a vertical shrink of a factor of 2/7, a horizontal shift left 3 units, and a vertical shift up 8 units. So what we're going to do, we're going to keep your x squared as x squared. And we're going to make all of your changes to that x squared. So your reflection over your x-axis is going to go in front of that x. Your vertical shrink by a factor of 2/7 goes in front of that x. The horizontal shift to the left 3 units means we're going to be adding 3 to the x, which means parentheses have to go around the x. That 2 gets moved out, and that +3 is on the inside with the x. Lastly, you have a vertical shift up 8 units. So the up 8 units is addition with the 8 on the outside. So you have f of x is equal to -2/7 times x minus 3 squared plus 8. For your last question, number 17, you are still using the parent function of f of x is equal to x squared. For this one, though, you have a reflection over your y-axis, a horizontal stretch by a factor of 4, a horizontal shift right 2 units, and a vertical shift down 5 units. So we're going to start with your x squared. First thing is reflection over your y-axis. So that's going to go directly in front of the x, and you're going to have parentheses. So I'd put parentheses around that negative x squared then. From here, you are horizontally stretching by a factor of 4. You're going to take this 4 and take the reciprocal of it because it's happening horizontally. So that 4 is going to turn into 1/4. That 1/4 goes directly in front of your x behind your negative. So I'm going to move your negative and your parentheses over, put the 1/4 directly in front of your x, the negative in front of that, and close the parentheses. From here, you have a horizontal shift to the right 2 units. So if it's right 2 units, it's going to be -2 on the inside. So again, I'm moving the parentheses and the power to be -2 on the inside. Lastly, you're going down 5 units, so it's going to be -5 after or on the outside. So altogether, you have that f of x is equal to parentheses negative 1/4 x minus 2 squared minus 5.